This program is brought to you by Stanford University. Please visit us at stanford.edu.
This presentation is delivered by the Stanford Center for Professional Development, providing graduate-level education to working professionals, online, on campus, and on-site. For more information, please visit study.stanford.edu.
Today, we're going to have one of our own, Brian Lee. He passed his orals and will talk about the work he did while he was here. And we're going to miss him, but maybe some of you out there will see him on his job circuit. So pay close attention when you listen to Brian Lee giving his talk.
Thank you. Thank you, Andreas. And thank you all for coming. Today I'm going to talk about my dissertation work on adaptive interaction techniques for sharing and reusing design resources. I'd like to begin by sharing with you two aspects of design that motivated my thesis work. As practiced today, design is rarely a solo activity. People work in groups, collaborate on projects, bounce ideas off of each other. What's interesting to note here is how, in design practice, artifacts structure communication. Storyboards, sketches, prototypes, all these things serve as communication tools the designers use to exchange ideas, communicate thoughts, and offer commentary. This is another picture. It's a shot of the product loft here at Stanford University. The first thing you notice when looking at this picture, this space is visibly active. There's a Barbie doll on the shelf, soft drinks and paint bottles line the desks. There's an umbrella hanging down, upside down off the ceiling. In this type of studio environment, you can see people go in and out or follow what they're working on by examining the clutter of their surroundings. Nowadays, with computers and mobile phones, some design activities take on a dual nature. Sometimes content is captured using physical devices, other times using digital. There are some significant advantages to digital devices, such as the ease of exchanging digital pictures and documents. Taken by themselves, however, digital technologies lose the natural visibility of using physical tools in physical environments. We believe that the emergence of digital tools as complements to physical tools for design practice is both a challenge and an opportunity. Specifically, we propose that augmenting designers' current physical and digital tools can enhance design practice. Let me go into a bit more detail. Today, designers create content both on paper and online. They spread their work over numerous physical and digital tools. Out in the field, designers use traditional pen and paper to take notes, while toting digital cameras and mobile phones to take pictures as another form of visual documentation. In brainstorming sessions, designers often gather around tables, chatting and jotting down ideas in their notebooks. The walls of design studios are often covered with sketches and drawings. At the same time, designers often sit with their laptops to send messages or produce documents. And in the meeting room, designers often use both physical whiteboards and electronic surfaces for presentations and group sessions. Here's a sample notebook entry from a design student enrolled in an HCI course here at Stanford. This page evidences a number of desirable features of paper. It's robust. It's really durable. It's lightweight. Paper can go anywhere. It doesn't matter what the conditions are. It's fluid. As you can see, it's an excellent medium for sketching and drawing. Paper is familiar. Everyone knows how to use paper. It's really simple. You just pick it up, and you've got a writing device, you've got an interface. And paper is ubiquitous. You can find it pretty much anywhere. The digital capture of content has its own benefits. Digital content is very easy to archive. You can store it. You can just upload it to servers. You can annotate it. One of the key advantages of digital content is that you can enhance things like reading and referencing it with things like tags and links. It's easy to replicate digital content. It's much easier to just copy a digital document than it is a physical item. And for that reason, it's also much easier to share digital content, especially among distributed groups. And finally, digital content is significantly easier to search. Thanks to the metadata usually associated with digital items such as timestamps and tags, it's much easier to search for digital things than it is to search through physical things. While digital tools have changed many practices traditionally done on paper, paper hasn't gone away. In The Myth of the Paperless Office, Sellon and Harper note that though email and electronic files have become the primary ways to share documents, lengthy items are still read and reviewed on paper. Similarly, in design, sketching and brainstorming still take place primarily in the physical realm. Contemporary studios, offices, and meeting rooms are filled with both physical and electronic artifacts, but these two worlds live apart, and the usual ways of moving between them, such as scanning and printing, are cumbersome and at odds with the freewheeling nature of a lot of creative work. Previous work has shown that augmented paper interfaces can bridge this gap between the two worlds, combining the ubiquity of paper with the flexibility offered by digital representation. Today, commercial products such as the Noto's digital pen system can digitally capture writing done in paper notebooks. We suggest that augmented tools can support design practice by integrating physical content into the digital realm while keeping the traditional workflow and advantages of paper. We don't want to replace paper, but rather augment it. Once the majority of design content is captured digitally, there is significant potential for improving collaboration and visibility in design practice through the sharing and automatic display of content. In particular, we believe that digital metadata enables new methods of browsing and displaying design content of interest. The thesis of my dissertation work does this. Augmented paper and digital tools can facilitate collaboration between designers and improve the visibility of design practice through the sharing and proactive presentation of design content. In support of this dissertation, we offer the following contribution. First, this thesis investigates the use of augmented paper and digital tools for capturing and accessing design materials. We designed and implemented a system which uses augmented paper and integrating sharing mechanisms to support the browsing and sharing of visual design content. Second, this thesis looks at adaptive algorithms for proactive presentation or automatic display of design content. We develop algorithms that use design features to select interesting sets of examples. These algorithms are implemented in a web page builder that automatically displays example web pages. And finally, we contribute evaluations of these tools and techniques in both laboratory studies and longer-term deployments. Next, I'm going to describe a little bit of the prior work that motivated this dissertation. In the area of augmented paper interfaces, there's a wealth of related research. The idea of shared electronic repositories for digital note-taking was first introduced by NotePals. The NotePal system used Palm Pilots for mobile input and web interfaces to display and share notes. However, the browsing interface was limited to recognize text and very basic properties, including timestamps and authors. Wendy Mackay, in her study of air traffic controllers, highlighted the use of paper flight strips as a tool both for information display and for social coordination between air traffic controllers. Her work underscores the importance of understanding the nuanced ways that physical tools contribute to work practices. Another inspirational system, Scott Clemmer's Designer's Outpost, combined a design time capture tool with a timeline-based browsing interface for retrieval of design history. Lisa Stifelman's Audio Notebook was one of the first systems to mix augmented paper with other media, in this case, audio transcripts. More recently, our very own Ron Ye worked on the ButterflyNet project, which examined how augmented paper could support biologists doing field capture and data transformation. I actually collaborated with Ron on the initial version of ButterflyNet, and this became one of the components in the work I'm describing here today. This dissertation extends this prior work in two significant ways. The first is that we offer a richer user interface for browsing and sharing design content. This research integrates augmented paper into digital images into a unified system for design ideation and documentation, and uses automatically captured and user-generated metadata to facilitate the sorting, searching, and sharing of design content. Second, unlike the systems listed here, this thesis evaluates our augmented tools in multiple month deployments, offering research insights and design guidelines from longer-term deployments of these kinds of tools. In this thesis, we drew on information foraging theory to improve access to design content. We wanted to enhance the information scent of design browsers by providing sense of potentially valuable information in addition to data the user specifically requests. The information model in this work draws on an idea of faceted metadata. And the key concept here is that metadata can be categorized into distinct types, such as time, tags, location, and media type. Hurst's work on faceted browsing allows users to browse a database of images using these facets. Our contribution lies in the use of the schema to improve browsing, sharing, and automatic display of design content. Finally, in our investigations into visibility lead us into the realm of model-based techniques for automatic presentation. Many systems have examined the automatic layout of information and interfaces. Probably the most closely related system in the literature is Supple, which proposed a constraint-based optimization approach to generating interfaces. In this work, we use a decision-theoretic strategy similar to that of Supple, but rather than addressing user interface layout, we address the layout of visual information sources, and we optimize along accordingly different metrics. We also drew technical inspiration from previous work on image browsers, such as PhotoMesa, and visual arrangement systems, such as the focus plus context view of George Furness's fisheye calendar, which use constraint-based algorithms to determine the number and size of items to be displayed. Lastly, one last piece of inspirational work was Shay's peripheral display of notes. He looked at the automatic presentation of note-taking documents. And in this thesis, his work focused on two basic selection heuristics: recency, how often someone's looked at something, and user-flagged importance, so they star it. In this thesis, we explore the use of design-oriented, faceted metadata to select interesting and inspirational examples for automatic display. The rest of my talk is organized as follows. I will discuss my research on two aspects of design practice. First, I discuss our research into supporting early stages of design, ideation, and documentation, with augmented tools for browsing and sharing design content. I describe our implementation, the idea's design ecology, and present findings from 4 longitudinal deployments. Second, I discuss research into supporting later stage design using the automatic display of examples. I outline design facet-oriented algorithms for subset selection and layout, describe a manifestation of these ideas in Adaptive Ideas, which is a design-by-example tool for building web pages, and I present findings from a first-use study of the tool. So let me start by just showing how we envision these tools being used in design practice. We have a group of designers is investigating augmented technologies for merchant farmers. They head out into the field, they're jotting down notes, they're taking pictures. They may be conducting interviews with subjects, they may be observing transactions with customers, they may just be being in the world and taking down their findings. Once they're back at their desktop, they can sync their pen, much as a Palm Pilot is synced, and the pen will automatically upload their notes from the day to the desktop computer and open up a design browser. The designer here can browse through his own notes or the notes of his coworkers. If he sees something interesting, perhaps he's putting together a report documenting his findings, he can highlight something and put it into a Word document. Or if he notes a picture that he wants to discuss with group members in his team, he can select it and email it out to other people. Or finally, if he actually wants to leave a comment or annotate a certain section of someone's notes, he can highlight it and leave a virtual post-it which says something like "cool," and tag it with keywords for future reference and searching. So to investigate these kinds of tools in an actual setting, we developed the Ideas Design Ecology. The Ideas system uses augmented paper to capture ideation and documentation activities, including notebook contents and digital images. It provides a faceted metadata browser for browsing, annotating, and sharing design content. And it also offers 3 integrated sharing mechanisms. Export, which is basically copy and paste of notebook and image content into other tools, such as email and word processors. Direct notebook viewing, so not only can you view your own notes in this digital browser, but you can also view the notes of your team members. And a third sharing mechanism, which we call group notebooks, which is a shared virtual space for groups, which I'll describe later in the talk. So first, let me explain the term ecology. The term ecology is adapted from biology, and generically, it describes a system that contains numerous interdependent elements. In this research, we use the word ecology to highlight the fact that the system encompasses not only a diverse collection of design tools and content, but of people and practices. We are not just interested in these tools, but we're interested in seeing how the tools actually change designers' practices. This is a high-level sketch of what's going on in the ideas ecology. The system comprises multiple devices, multiple people. And within this, we define two broad classes of artifacts. The ideas notebook encompasses designers' capture devices, including augmented paper notebooks and digital devices such as digital cameras and camera phones. The ideas browser is a digital browser for accessing design content, which affords faceted browsing, search, annotation, and sharing of design content. We use the Enoto digital pen and notebook. This is a commercially available system. And these pens record a vector graphics representation of every stroke made on a notebook page, along with the page, date, and time. Users can upload and view these digitized notes by synchronizing with their PC, as I mentioned earlier, much like a Palm Pilot. Mobile digital computers such as the tablet PC offer some of the same functions as these Enoto pens, particularly mobility, the ability to go around things, and the ability to do pen-based input. However, these devices have two distinctly different affordances in the real world. In normal situations, both tools offer digital capture of written materials. The difference here is that the Enoto pens also offer physical capture, since they're just normal ballpoint pens embedded in the pens. So they offer both physical and digital capture. If the pen digitizer fails, for instance, if the pen runs out of power, users can continue taking notes and sketching as if they were writing with normal pen and paper. If you can contrast this with the behavior of a tablet PC, where if you run out of power, you don't get anything. The ideas ecology also integrates images captured by other electronic devices, such as cell phones and digital cameras, by allowing users to upload their images to the online photo sharing site Flickr. Captured content is primarily accessed from the ideas browser. So here's a screenshot of the browser here. On the left, users can browse general content, notebook pages, photos, etc., in the content panel. On the right, other content related to the content in focus, such as pictures taken around the same time or linked to the pages in question, are displayed in this context panel. On top, there's a timeline visualization, which visualizes the content, in this case, the number of pages written on each day, and along with flags which denote important events in the project or in the project or group. Users can apply tags, which are keywords, or annotations, which are virtual post-its, to any content. And these textual annotations can be searched using the search bar in the upper right there. So those are that's the basics of the browser. And the browser also offers three sharing mechanisms. The first is export of excerpts of design material. So the user, as you saw earlier, can highlight material from their notebooks or whatever and post it in, and paste it into things like emails or Word documents. The second sharing mechanism is direct view. So not only can you view the items, the contents that you've generated, but you can also see other people's notebook pages, other people's pictures, etc. And finally, we introduced this concept of the group notebook. So generally, when collaborating, designers need a place to put shared content. Today, they do this in a number of ways. They do this using shared Gmail accounts, networked file systems, blogs and wikis, or sometimes they just all maintain separate shares and just email out stuff to the group when it's needed. We introduced this concept of group notebooks to serve as shared, persistent digital repositories for group design content. So anything you can put into your own notebook, into your own repository, such as notes and photos, can be put into your group notebook. And so the idea behind this is that each person contributes to this set of shared content, which things are explicitly selected and thrown into the group notebook. And by default, it's sorted in the order contributed, but users can reorder this virtual notebook by other dimensions, such as creation time. At a high level, this is the architecture. this is the Ideas Architecture. So we have the user's augmented tools. So he has an Anoto digital pen and his digital capture device, say a digital camera. Pen strokes are uploaded to the Ideas design repository, which is a centralized server for holding notebook data for the entire group or a group or lab. Digital images are uploaded to the online photo sharing service Flickr, which is an existing service. It's another commercial service integrated into the Ecology. And the Ideas browser ties all these things together to produce a seamless browsing experience for all the user's design content. So as I mentioned before, we use a lot of off-the-shelf hardware and software. And our research software ties all these things together to support existing behaviors while enabling new behaviors and support such as sharing and annotation of things which couldn't be done before. So over the past 2 years, during my time here at Stanford, we've conducted 4 10-week-long deployments of this system to students in HCI design classes here at Stanford University. Why do we choose students? For a couple of reasons. The first is that it was easier to get access to classes here at Stanford than, say, professional design firms. But we were also interested in the effects of this kind of ecology of tools and content on learning and education. These studies were carried out jointly with Heidi Maldonado, who's a PhD candidate in the School of Education here. In these studies, participants were given the Anoto digital notebooks and pens, as well as the Ideas browser and the related software to get these things to work together. We observed these people and collected data through 4 general methods. To find out what tools designers actually use and why they use them, we conducted field observations. We observed student designers in class, in discussion sections, in group meetings, and out on field trips. In order to find out how various sharing mechanisms were actually used by participants, we logged interactions within the ButterflyNet browser. So every action that a user took while the digital browser was open was logged to a file. The third study method we used were questionnaires interviews. Participants were given extensive post-experience questionnaires, asking them about things like group behaviors, tool use, sharing, and other items of interest. And finally, thanks to these augmented tools, we had access to reams of physical and digital content from design notebooks. We also analyzed course submissions and evaluations. In all, more than 100 study participants have used some version of the Ideas tools. We captured more than 6,500 pages of design content and hundreds of digital images. From all this, we gathered some high-level results, which I'll describe now. So the first thing we found is that export was an especially valuable mechanism for sharing design content. The Ideas browser lowers barriers to excerpting content created in paper notebooks. The Anoto technology made this process more fluid, and the Ideas browser made it easier to find relevant materials through its tagging and search mechanisms. The export of content allows designers to migrate visual content into larger ecology of productivity tools, such as email and word processors. So we don't have direct comparisons versus prior editions of the classes in question, but we do have 2 data points in support of this conclusion. The first is self-reported use of browsing, copying, and pasting mechanisms. And this is corroborated by our observations and logs of people using the system, which indicated that export was by far the most popular sharing mechanism, and was used regularly by adopters of the technology. The second data point was excerpting into submitted assignments. So this is a couple of typical assignments done in the classes. And so one thing you can see is the insertion of digital images into content. This is a commonplace practice beforehand. Digital cameras have been around a long time. People often insert pictures to show what they saw, what they did. But you also see here examples of ideation, examples of diagrams and sketches. And while these were always available before, inserting these things into design submissions, course submissions was not a commonplace practice in previous editions of the course. And so this points to one example in which these augmented tools actually affected design practice by allowing people to insert things, samples of their ideation and other sketches. Our second finding has to do with the architecture of the ecology. So earlier versions of the system required users to import their images into the design repository. to the design repository. So all the content related to designing was stored in here. However, for many users, this means that they had to actually keep 2 or more distinct repositories of digital content. So people who were using things like Flickr already had to have 2 separate repositories for their digital images. And so in response to that, we decided to, the new architecture integrates Flickr directly into the ecology. So digital images are stored on the Flickr service, servers. And later, images and metadata are accessed through the Flickr API and displayed directly in the IDEA's browser. We believe that this reflects a broader principle, which is that augmented tools such as these should be designed to fit existing digital practices as well as physical practices, wherever possible and wherever practical. If there's an off-the-shelf solution that's available and already does the job, a lot of times there's no sense in reinventing the wheel. If they've already done it, you should use it. And in fact, as we observed here, redundancy can actually detract from the user experience by adding user burden for adopting our system. Our third finding has to do with the coexistence of paper and digital. So this is an example of a user's digital notebook. This is one of the notebooks actually used in the studies. And as you can see, they wrote in it with the digital pen, but there's also all these physical items pasted into the image, this notebook. The physical world has material which the digital world does not, and vice versa. And in our studies, students appear to maintain multiple distinct repositories of design content. They move media between them as the need arose. So, hybrid resources such as this notebook will probably continue to exist, but we found that our augmented tools lowered the threshold for moving things between the physical and digital realms, and thereby encourage more mixing of media between physical and digital sources. And so our fourth finding has to do with patterns of adoption. So one of the interesting things that these augmented pens allow us to do is track when people actually wrote with them. So there's a little clock embedded in these pens, and people can see, or we can discern when they actually use the pens to write content. And so on the right here is a set of spark lines generated by Heidi Maldonado, showing the number of pages written with the digital pen over the course of 1 quarter, in this case, winter 2006. And we've classified these users into 2 broad categories. There's a set of users, many of them, who use the system more or less continuously throughout the quarter. But there was another set of users who only gave the technology an early try, but abandoned it after limited use. And so we were curious to find out why people did or did not adopt the technologies. So we asked people why they did or did not adopt these things, and participants outlined 2 main concerns. The first adoption challenge was the augmented paper hardware itself. So as I showed you earlier, there was this augmented pen, but users complained about the pen's ergonomics. The pen was really fat. It's not like most of the pens you guys carry around these days. There's a camera embedded in them, so the ergonomics of the pen were not ideal for many designers. The pens required maintenance, so people had to remember, oh, I got to charge my pen, and this overhead was enough to detract from the experience for many people. And also the reliability of the digital capture. So the pens were good, but not 100%. And when they failed to recognize or to save your data, people got annoyed by that. None of these issues were inherent to our research approach, but they are important to understand how people use these tools in real life. The second challenge that participants outlined and we observed had to do with sharing of permissions on captured content. So while I mentioned that the export sharing mechanism was wildly successful and a really popular thing among designers, the other 2 sharing mechanisms were not nearly as widely adopted. And we found 2 reasons for this. So the direct notebook view erred on the side of inclusivity. So by default, any group member could look at any other member's notebook for people in their group. And people were uncomfortable with this. They were comfortable with the possibility of private notes being revealed to other group members, even among close-knit groups. So the IDEA's system, as instantiated for these studies, did not provide any way for users to keep certain content from being shared. Group notebooks had a slightly different problem, and they erred on the side of exclusivity. So by default, things were not contributed to these group notebooks. Instead, users had to go back and look at the pages in the digital browser and explicitly decide to add them to the group notebook. And the overhead of doing this, of going back to a page and adding it later, deterred many people from using this function. We believe this highlights an important distinction in design between these types of ubiquitous systems and traditional computing systems. So in traditional computer systems, there are very rigid location and permissions formalisms, what directories I can see, which directories I can't see, which define which files are accessible by whom. On the other hand, in these kind of more ubiquitous systems, you often lack these kind of structures, directories or formal storage structures. And so the default settings, whether you err on the side of including everything or including nothing, tend to be the settings that reign supreme in the actual use of these systems. And so we drew two high-level conclusions from these studies. So the first is that users tend to excerpt and share more when using these augmented tools due to the lower barriers to capture and the better browsing and sharing mechanisms. However, the second conclusion that we found is that users tend not to adopt features where the perceived costs were greater than the added value. These costs can come from a number of different directions, whether it's privacy and permissions, or it's added user burden by making people do extra work to get the added benefits. We suggest people who saw the value in these tools went ahead and used them anyway, but not everyone went ahead and jumped in. And so we suggest that it's important to illustrate the benefits of these new tools, for example, by drawing analogies to existing tools and practices, while minimizing the costs inherent in adopting them. So minimizing costs. So that was the first half of the dissertation, which looked at how to support early-stage design, ideation, and documentation activities with this kind of augmented tools. The second half of my dissertation examines how we can augment later stages of design practice by automatically displaying examples of inspirational design. And so let me set the stage again with a scenario here. So here's a typical design task interface. So this is a web page editor. It's a WYSIWYG web page editor. Users can edit the web page by hand. But oftentimes in designing a web page, a user will consult examples of other web pages. But finding a good example web page is not a straightforward process. One way to do this is look at Google. Google for someone's random homepage. Keep looking until you find one that you actually like, and then copy it to your original design. What if, instead, a web page builder had a built-in space for displaying examples? So users could browse inspirational designs directly in the tool itself. And the central research question for this scenario is, how can we automatically find and display an interesting set of examples for a user in a given design task? So to investigate this kind of example display in a concrete system, we developed Adaptive Ideas. Adaptive Ideas is a web page builder which augments a traditional editor with automatic display of example web pages. It uses facet-based distance functions in order to find interesting sets of examples to display. So I'm going to first outline the architecture of the implementation and describe a first-use lab study of the tool in action. So in our approach to this design by example idea, content is drawn from a corpus of example design resources. So someone's put together a set of examples, and we wanted to display some subset of those during the design task. Content elements have attributes, which are facets, as I mentioned earlier. These are categorizations of the content along interesting dimensions. And so in this work, we focus on visual properties as attributes. So things like colors, fonts, and more abstract properties such as density of visual elements. And so these are different ways to classify web pages along dimensions of interest to designers. To compare elements, we use this concept of distance functions. A distance function models the difference between two attribute values and is defined on a per attribute basis. For example, in our implementation, to compare two colors, we use a Euclidean distance between between the colored points in a biconic hue saturation value space. On the other hand, to compare fonts, we use a very simple ternary function. 0 if they're the same font, One, if they share serif characteristics, so serif or sans serif, and two, if they just have different serifs. And we use these kinds of simple, Euclidean distance serif comparisons as functions because they're simple calculations. And since we're not seeking optimality necessarily here, as long as these functions produce distinctions of interest to designers, that's all we really need from them. So we define two. I'm sorry. Yes.
Font size.
Yeah. So fonts. We didn't actually account for font size with a different axis. We didn't. But in this particular study, we only looked at font face. We didn't actually just do distinctions of font size in this particular. But that's another dimension along which you could imagine dividing different fonts. So we have these different criteria. What do we do with them? So we define two criteria of interest to displaying design examples. And the first is similarity. So the idea behind finding similar items is that you want to find a subset of all the items in the corpus, say n items, most similar to a given element for a given design attribute, axis or axes. And so we use a very simple algorithm to find this. We select the n elements in the space which are closest, that is least distant, from the given element. And you see these kinds of similarity algorithms all over the place. Any search engine uses, in their relevance algorithms, uses this kind of similarity matching. And so this is a two-dimensional representation of design space. So these are the black dots represent examples which have specific attribute values for the design axes here. You'll notice that it's chunky, so there's some clusters. And if I want to find things most similar to a given example here in the center, I just take the n least distant items, which happen to be these 5 here. And so that's pretty simple. The other selection criteria we use is variety, which you can also think of as dissimilarity. So the goal of the variety subset algorithm is to find a set of n objects which represent a diverse subset of objects along a given attribute axis. We hypothesize that showing a well-selected variety of examples along a given axis would give designers a better feel for the overall attribute space, and thus provide better inspiration. But this raises the question of what defines a well-selected variety. So a naive variety algorithm would probably just take, at random, n elements from the space. And so if you just select, say, 5 elements from the space, what you'll probably get is something like this, which are, and this particular algorithm shows you a number of elements from that cluster up there on the right, but doesn't give any impression that there are other examples in the space down here on the bottom left. And so we chose a different variety algorithm, which takes a space stochastic approach to finding a variety. So we select elements with a minimum distance epsilon between them. And this kind of technique is applied in computer graphics for point sampling, and also in dissimilarity algorithms for selecting diverse subsets of chemical databases. So in this space stochastic approach, the system picks a random example to start, and then the next example it picks comes from the set of examples which are at least epsilon distance away, and so those examples are eliminated. And so it continues picking examples with at least a minimum epsilon distance away from all the previously picked examples until it finds a number of examples it wants. And so the choice of epsilon has significant influence on how this algorithm behaves. So when epsilon is small, when epsilon is 0 or small relative to the space, then this algorithm degenerates to the naive case, which I outlined 2 slides ago. When epsilon is, the larger the epsilon gets, the harder it becomes to fill up the space. So if you select an epsilon that's too large, you eliminate all the possibilities. So for this work, we selected a large epsilon such that the theoretical maximum number of elements you select is slightly larger than the number of elements that you want to find. And so this particular variety of possible values may be more desirable, since it allows users to see a kind of a fuller picture of the design space. On the other hand, such an algorithm may emphasize outliers or unusual points in the design space. And so that's a trade-off that you have to consider in the algorithm design. This is the architecture of the ideas, the adaptive ideas approach. So we give the system 5 inputs. The first is the user's the user's focus, what he's currently working on. The corpus of examples that I mentioned earlier, from which we draw the examples for inspirational display. The actual interactive elements, so the editor and the other elements that need to be displayed on the interface. A set of valuation functions which tells us how valuable it is to render a given item at a given size. Generally, larger items are more valuable because they're easier to see. And a template which specifies the general layout of an interface, but not necessarily the sizes of the particular elements. These inputs are fed into a generator for adaptive interfaces. And for a given interface, we request an example, a set of examples. So the generator asks for a set, 20 example display from the example subset manager, and the subset manager just spits out 20 examples which are similar or a variety depending on what was requested. And we produce an HTML output, which is then rendered to the rendered to the user. So to evaluate the usefulness of this approach, we constructed an example-augmented tool for a concrete design task, building a web page. There are 3 parts to this interface. The first is the what you see is what you get web page editor. This is the traditional web page editor. You can edit things by hand by clicking on there and typing in it or editing the fields there. But we also have this space below here, which has to do with display of examples. And so this is an example display area, which shows a variety of variety of items or similar items, depending on what was requested. And then if you want to see an example an example in a larger size, you can put one in focus by clicking on it. And this allows you to see the example up close and see the details better. So users are initially presented with a variety of items, as you can see here, a variety of background colors, to emphasize the variety of the design space. But you can also choose to browse items similar to a given item by clicking on this text box here and asking to see items with a similar, for instance, a similar background color. So if I select similar, you get items with similar background colors in this space here. And so you can use these features to browse through the space of the corpus of examples along axes such as background color or font and the other things I described earlier. We also support cut and paste feature reuse. So if you find a background color that you actually want in these corpus of examples, you can actually just select the feature by clicking on one of the buttons here, and that feature will be copied to the point in which you click in the space in the page that you're editing. So to assess the usefulness of this approach, we conducted a comparative laboratory study. We invited 9 people to participate in a first-use study, and we conducted 2 conditions. The first condition was adaptive browsing, which basically uses the features that I described earlier, the similarity and variety tools for browsing examples. And the second condition presented users with random subsets of examples. So instead of seeing examples organized along a given design axis, the examples you saw earlier were just on the right here, were totally random. They were selected at random. And so we believe that this kind of random selection of examples models the finding examples by Google approach. So when you're browsing through home pages by surfing the web randomly, you can find a lot of examples, but they're not necessarily organized along any design attributes that you find interesting. And so we believe that showing people random subsets of examples kind of models this, go out into the web and find examples until you find something you like approach to designing a web page. Participants were asked to design 2 web pages, one for each of 2 different personas, using a different version of the interface for each task. So the personas and the features were varied. The pairings of these personas and features were varied using a Latin square ordering. And so let me describe the results, 4 items here. And the first result that we found is that, in general, users found the examples helpful. So users rated the proactive display of examples and the variety browsing tool, the ability to see varieties of examples along a given design axis, to be helpful in finding examples that they actually wanted to see. The second finding that we found is that the adaptive features were actually helpful to users. So study participants found that the variety and similarity tools made it easier to navigate this corpus of examples than the random display, which you could only browse linearly. We found some differences in the adoption or the liking of this interface between novices and experts. So novices particularly appreciated having these tools integrated into an example, into a design tool. So these values, these ratings were both higher for novices than for the overall average. However, experts had kind of distinctly different views on the use of examples in a design tool. So the two self-rated experts gave different opinions. The first expert didn't like the use of examples in general. This expert felt that the augmentation actually distracted from the design task by taking up valuable screen space, and so he basically felt that the space dedicated to the example slate could have been used for actually editing the page, and just added to the clutter of the interface in general. The second expert actually felt that this augmentation actually aided her building strategy. So her strategy for building a web page was to actually go out and find examples and find something they like, and then modify or tweak or borrow from those examples until she had something that she liked. And so this augmentation actually aided her strategy by proactively offering examples and searches which are organized along actually interesting design axes. And so both novices and experts requested the ability to sort along different axes that, other than the ones we described earlier, such as aesthetic and social attributes, like the funness of an interface, the funness of a web page versus the academic, versus academicness of an interface. Quantitatively, we found that participants browse on average half as much when using our variety and similarity tools than when using the random tools. And so we hypothesized that these kinds of variety and similarity-based browsing tools allow designers to more efficiently form a kind of mental model of the space for a given design attribute. And so overall, we drew the following conclusions. So augmenting this kind of design tool is a promising technique for providing information and inspiration in design. And in particular, we believe that this proactive presentation and faceted-oriented browsing of examples can actually aid designers in their design tasks by facilitating discovery and exploration of design alternatives. So I wanted to conclude the talk by just jumping back to some of our the motivating beliefs behind this dissertation work. We believe that augmented paper and digital tools can facilitate collaboration and improve the visibility of design, or in design, through novel mechanisms for browsing, sharing, and presenting design content. We like augmented paper because it supports existing paper-based practices while offering some of the benefits of digital representation. And we like digital representation because it offers new ways to browse and share content thanks to digital metadata. This thesis offers contributions in two areas. The first is a system for augmented paper and digital tools for ideation and documentation, which supported browsing and sharing of design content. We introduced some lightweight mechanisms for documenting and annotating design content. And we added methods for facilitating collaboration through the sharing of these design artifacts among group members. And we deployed and actually evaluated these systems in multi-month deployments. Broadly, we found that lightweight mechanisms for excerpting content were very successful and very valuable, but adoption issues such as privacy and permissions made some more direct and explicit sharing experiments less successful. The second half of my dissertation work looked at using adaptive algorithms for proactive presentation of design content, supporting the design by example approach to design. We looked at novel methods for increasing the visibility of these examples through using facet-based variety and similarity algorithms for selecting these subsets of examples to display to the user in interesting ways. And we evaluated this approach through a first use study of example reuse in a web page builder, finding that it actually had an effect which was to make browsing quicker and more efficient. I wanted to acknowledge some of the people without whom this work would never have happened. In particular, my coworkers and collaborators on a lot of this work, Heidi Maldonado, Ranier, and Wendy Ju. Without them, this stuff would never have gone through, and their boundless enthusiasm and creativity never fails to amaze me. I had an opportunity to work with a lot of wonderful undergraduates during my time here at Stanford. Seville, Isabel, Paz, Laura, Mike, and John. Just amazing. Stanford students are really smart, and coming from Berkeley, it's really hard to say that. So I just thank you guys all for all your wonderful work. My advising committee, including my two principal advisors, Scott and Terry, just two amazing people in the field of HCI, and funding agencies for making sure I wasn't poor. So in closing, I wanted to offer a couple of thoughts here. This dissertation offers small steps toward the vision of these kind of augmented tools and techniques for design, which respect the best aspects of paper-based practices and design activities, while creating richer interaction experiences for designers in different stages of design. We think that paper gets a lot of things right. We have a very familiar, very nuanced relationship with paper, and it seems unlikely to lose its place as the designer's best friend. At the same time, designers, through the miracle of digital technologies, designers can do things now they couldn't imagine doing just 20 years ago. I can search through a database of millions of digital images, searching for just the right example, and that's just something that's just amazing. It has so much potential to change how we think about design. We've only begun to look at how augmented tools can enhance design practice, and it's just a really exciting time to be doing design. And as a designer and a researcher, I look forward to seeing what comes next. Thank you all very much. I'll take your questions now. Yes?
I had a question about the ideas browser that you had earlier. I noticed, sir, you mentioned that there was a timeline on top. What kind of reaction did you get from users? Was it useful to them to actually see a timeline of their work, or what was the thoughts behind that?
So the question was, so I mentioned earlier that in the ideas browser in the first half of the talk, there was a timeline visualization of content up there, which in this case displayed the number of pages written on a given day. And the person there asked what was the user's reaction to it. Several users commented that it was actually very useful. And the reason that they cited was that usually, since their activity was bursty, that is, they'd write a lot on a given day when they went out into the field, when they had a meeting or whatever, the kind of these histograms, these bars, gave them a very good impression of when things happened. And so they said, oh, what was that meeting that we had like a couple weeks ago? And just by looking at that timeline, you can see, what there was activity on the 21st of November or whatever. Click to that, and actually it would open your notebook pages from that, which I didn't mention here. If you click on a timeline, it would actually bring you to content you generated on that given day. And so it was another way for people to index into their design resources using the timestamps from their design content. And so several people commented that was actually useful. And yeah, there are definitely other things you could do with that kind of visualization, but that was the one we used there. Yes?
Can you give some more examples, or maybe make it a little more concrete for me, for the idea of creating something by searching for examples that are similar or dissimilar on some dimension?
Okay. So the question here was just kind of a clarification or an elucidation of what we mean by designing by example, why similarity and variety is useful, and if I'm understanding the question correctly.
Concrete examples of how people would use it.
And so well, the way that people would use the system, and the way that or at least the way the study was structured, is that people could browse examples along a given axis. So people could look for items with, say, a background color which was similar to a blue that they liked, or they could search for a font which had shared serif characteristics. Like they wanted a different serif font, they could search for things with the same serif characteristics, or they could search for things of so text color was another one. Or they could search over another axis we implemented in the study was visual density, which was coded by hand by a researcher, which looked at basically how cluttered the interface was. Was it very sparse, kind of like that Zen-like approach where you have a vast field of color and just some text or images, or was it filled with text, right? And so users could browse either along similarity. We have an example. We want to see other things similar to that, or variety. I want to see a variety of background colors. And so people use the variety tool to see what was out there. And so when they started tabula rasa from the white web page, nothing on it, they could look at it, they could actually specify and say, I want to see a variety of background colors, and that would show them what background colors actually people had actually used. And they could specify, okay, let me see, if I find one they actually kind of like, they could click on that and bring that into focus and say, okay, show me other things similar to this. So I found a red that I like. I'm from Stanford, I like red. So I found this red. Show me other reds, or show me other things close to this. They might show you the kind of dark reds or light reds. And so they could browse through the space and pivoting along different axes. So I found this red that I like. Show me things similar to it. Okay, I'm done with that. Now let me see different fonts or different. And so basically they could consider a given attribute, browse through using the variety tool until they found something that they liked or was close to what they liked, and then use the similarity tool to drill down into things around that area. We didn't include any explicit visualizations of the design space. We just showed examples. But you can imagine an extension of this idea where you actually have a two-dimensional rendering of examples of the design space, and you say, okay, show me these reds around here, and you click down there, and it jumps down there. But for this work, we just took the approach of showing examples and allowed people to pivot along those specific examples. Yes?
For showing those examples, do you think it was important that you showed them in the website versus just I'm interested in different reds, so it just brings up a color palette of different reds, or I'm interested in different fonts, so it just brings up you showed the different fonts, but just one word of it.
Right. So Kriya's question was, for the example augmentation, was it important to actually show real examples versus just showing specific data points? So, for instance, a given font, a given color, a given design value, whatever. And so that's not a question we answered. So that's one thing. Is that my thoughts on it? If I can just off the top of my head here, is that by using concrete examples, people can see how design values interact with each other. And so I could show you a red, or I could show you a red in a real web page. And so for some designers, showing you red might be better. So I just need Photoshop. What do I need? What do I need a web page augmented editor for? But for people, particularly novices, who may not have an idea of how different design values interact, seeing real examples might be a good way to to actually understand how things. So why is red on yellow bad? Well, here's why. That kind of thing. Okay. Well, thank you guys very much.
For information on other online Stanford seminars and courses, please visit study.stanford.edu.
The preceding program is copyrighted by Stanford University. Please visit us at stanford.edu.